here we go. So if you guys ever want to watch the lesson again, you can. All right, this is 2.4. We're on day 2. Before we continue, I wanted to do an extra problem with you. So before example 8, or at the bottom, you see where you have your trigonometric functions in the chain rule. I wanted to do an extra example. If you want to find dy dx, if y equals 3t squared plus 1, and x is 8t minus 5. Right, are there any open bags? So here's more, just as needed. So yesterday we talked about this a little bit. You want to find dy dx, and this is going to be a potential exam question. So what we're going to do is, in the first equation, we can find the derivative of y, but it's with respect to time, or t, so that's 6t. Over here we have dx dt, which is 8. Okay? But what we're trying to do is we're trying to find dy dx. Well, I have dy dt. I can't multiply by dx dt because that wouldn't cancel the dt's. So what do I actually need to multiply by? The reciprocal, which would be dt dx. So this is 6t times what? 1 over 8. So that's what? 3/4. Whoops, wait a minute. Did I do something wrong here? Yeah, no, it's just 3/4 t. Except that's not in terms of x, is it? Mm-mm. So how can I then put it so that it would actually have an x? Any ideas, Ian?
You can solve the second equation for t in terms of x.
Good job. All right, so that's what we'll do. We'll add the 5 and divide by 8. Do you guys understand that back here to dy dx, that has to have an answer that's in terms of x. So then this is going to be 3/4 times x plus 5 over 8. So it's not necessarily a pretty answer, but that's it. Okay, that would be the derivative. Okay, on page 135 are the chain rule versions for the 6 trig functions, but it's really rather simple. Let's look at example 8. If I have y equals the sine of 2x, y prime, the outside function is sine, so I'm going to take the derivative of the outside, leaving the inside alone, times, and then I have to find the derivative of the inside. So this is going to be 2 cosine 2x.
That's the answer?
That is the answer. Letter B. I'm going to find the derivative of the outside. So what is the derivative of cosine?
Negative sine.
Negative sine. You leave the inside alone. Times the derivative of the inside. What's the derivative of x minus 1? 1. So this is just negative sine the quantity x minus 1. In the third one, y prime, I take the derivative of the outside. What's the derivative of tangent? Secant squared, you leave the inside alone, times the derivative of the inside, which is 3. So it's 3 secant squared 3x. Okay, any questions on those 3 examples? It's pretty straightforward, isn't it? Okay.
I hope the rest of it is.
All right, in example 9, it says where you're putting your parentheses. So in letter A, the 3 is inside the cosine. So this is going to be negative sine 3x squared times the derivative of the inside, which is 6x. So to tidy that up, I would get negative 6x sine 3x squared. Letter B, I have y equals, now that's a cosine 3 out front. What is cosine 3? I mean, just in general. I mean, I don't know exactly what it is, but cosine 3, that's not a variable, right? That's a constant. Cosine 3 is some number. Well, actually, can you do cosine? If it were radians, I could do that, right? So if you do cosine pi. Okay, but anyway, so if I want to do the derivative, this is just some constant. And so I'm actually finding the derivative of x squared with a constant in front. So you would bring down the power times the x. Do you notice there's no sign or negative sign because I'm not actually finding the derivative of cosine. It's not the cosine of x or the cosine of something with an x. Do you see that? Okay. All right, now in letter C, the outside function is cosine, so that's negative sine of the inside. Now, the inside is 3x being squared. You could figure this out one of two ways. You could either square it, and that's 9x squared, right? And then you're going to find the derivative. Or I can bring down the power, decrease the power by 1, and then find the derivative of that inside. We're eventually going to need to do that to understand it, but if that's a little bit confusing right now, remember 3x being squared, I don't know why I just put a 1 in there, is 9x squared, and its derivative would be 18x, which is what I'm getting, okay? All right, letter D. I need to remind you, I know that you know this, but when we write cosine squared x, that's another way to say you have cosine x, the quantity being squared. So to find its derivative, the big or the outside function is something's being squared. Well, how do I find the derivative of something being squared? Bring down the power, decrease the power by 1, and then you've got to take the derivative of the inside, which is negative sine x. Now, I want to do a little fancy footwork here. Do you remember, because this is going to creep into the AP exam, do you remember this trig thing? And I think we wrote this down the other day, that the sine of 2x or 2 theta is 2 times the sine of x cosine x? Do you remember that? And we wrote this down. So how could I tidy up? Yeah, do you see that I could replace 2 sine x cosine x with sine 2x? Now you don't need to do it in general, but when it comes to the multiple choice section and you're looking and you're like, I know I did this right, but I don't see this answer, you've got to remember your trig identities and trig substitutions. All right, I'm just really trying to help you here. All right, how about in letter E? Y equals the square root of cosine x. I think what I would like to do first is rewrite it as y equals cosine x to the 1/2 power. So then if I go to find the derivative, the outside function is the square root, so I'm going to bring down the power, decrease the power by 1, and then find the derivative of the inside. So this is negative sine x over 2, and that's really cosine, square root cosine x. if they write a square root, then you probably want to have your answer with square root, but it's not wrong if you leave it as to the 1/2 power. You do not need to rationalize, okay, rationalizing, but we do need to take care of negative exponents. All right, any questions on those 5? All right, example 10. If you have f of t equals sine cubed of 4t, and you want to find f prime of t, this example says we want to look at the repeated application of the chain rule. Okay, so the big operation is something's being cubed. So I'm going to bring down the power and decrease the power by 1. But then I have to find the derivative of the inside. The inside is sine 4t. Do you guys understand that? That the inside is the sine of 4t. Well, how do you find the derivative of sine 4t? Well, that's the cosine of 4t, but then I have to take the derivative of the inside. So do you see that I've had to do the chain rule twice? So this is 12 sine squared 4t times cosine 4t. Sure, absolutely. Okay, when you're looking at f of t equals sine cubed 4t, the outside function is something's being cubed. So I bring down the power, decrease the power by 1. And then I need to find the derivative of the inside. The derivative of the inside is if I had, let's say, off by itself, the sine of 4t. Now I'm finding this derivative. Well, you do the derivative of sine, leaving the inside alone, and then you have to take the derivative of the inside. Okay, so you're doing the chain rule twice. Okay, good question. All right, last example says, find an equation of the tangent line to the graph of f of x equals 2 sine x plus cosine 2x at the point pi, comma 1. Then determine all values of x in the interval from 0 to 2 pi at which the graph of f has a horizontal tangent line. Okay, so you notice that in almost every section we have been asked to write the equation of a tangent line, and they are going to continue to ask us that. So if I want to find the equation of the tangent line, I need to find the slope, and we find the slope by finding the derivative. So this would be 2 cosine x, and then that's minus sine 2x times a 2. So do you see how I can sort of pause it, leave a little space, and then put that 2 out front? And then the slope is at pi. So this is 2 cosine pi minus 2 sine 2 pi. Let's do a very quick unit circle refresher. Okay, so here's 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So what is the cosine of pi? -1. And what is the sine of 2 pi? 0. So this is -2. That's my slope. And I have the point pi, comma 1. So we're going to use point slope form. And this would be y minus 1 equals -2 times the quantity x minus pi and I can add 1 to both sides. You can leave it like this, or you can use the distributive property, because you can't add together 2 pi plus 1. So there's your equation of the tangent line. Now we're going to do the second piece that says then determine all values of x in the open interval from 0 to 2 pi at which the graph of f has a horizontal, and that should say tangent line. Horizontal tangent lines occur where f prime of x equals 0. Well, we found f prime of x, so what we're going to do is we're going to just set it equal to 0. Now, it's a good thing on the previous slide we reviewed what the sine of 2x is equal to, because we're going to use that substitution. Well, sine 2x is 2 sine x cosine x. So do you see this 2 is this 2 right here? But sine 2x is 2 sine x cosine x. So I'm doing a direct substitution there. So this is 2 cosine x minus 4 sine x cosine x. And then I can factor it. And so then it's a good thing in pre-calculus we spent time solving trig equations. So I'm going to set 2 cosine x equals 0, or 1 minus 2 sine x equals 0. Now this says from 0 to 2 pi, but there's parentheses, so that means 0 and 2 pi are not included, right?
Correct.
Okay, when it's an open interval like that, 0 and 2 pi are not included. So this is what, pi over 2 and 3 pi over 2. Looking at my little unit circle. On the other equation, I'm looking at where sine x is equal to 1/2. All students take calculus. That'll be in the first and second quadrant. What's the reference angle to give me the sine of that angle is 1/2? Ian?
Pi over 6.
Pi over 6. So that's pi over 6 and 5 pi over 6. Now, it just said, thank goodness, all the values of x, so we don't have to go find ordered pairs. If we did, we'd go plug them into f of x to find it.